Today I'm going to be discussing about the refraction of light. So let's say we have a light ray that hits a water. So let's say that's another medium, that's water. So this light ray, I'm just gonna put an arrow here, a red arrow. So let's say this is a light ray. Here you have it. And then that light ray will cause some, okay, let's say we have a medium. The medium is going to be air. This medium is going to be the water. So what really is happening here? So this is another angle that basically expands. So it moves away. So why do this thing moves away? So why does it moves away? It's basically because of their index of refraction. Okay, so I mean, let's say refraction of light. Okay, it is due to the refraction of light. We all know that this light ray will this law of reflection. We have a reflection here, and this is going to be the refraction. So they are two different things. So so refraction of light. It is a property of light that causes to bend when it passes from one medium. So that one medium here is going to be the water that causes it to bend. So this is air and this medium is water. So we have water. So this is caused by the index of refraction. The index of refraction of air is just going to be 1. So we have a symbol N here. And the index of refraction of water is going to be 1.333. So an N is the index of refraction. I'm gonna note it here. Okay, I just doubled my E. There you have it. And now, to calculate that angle, we need to use Snell's law, which is n sub 1 multiplied by sine theta 1 is equal to n sub 2 multiplied by sine theta 2. And also, speed of light depends on the medium it travels. So the speed of light, the new speed of light is going to be still the constant speed of light, because speed of light is basically constant, and divided by the medium. So as we can see here, the n is just 1. So the new speed of light is just equals to its constant, which is 3 times 10 raised to the 8th power. So we have another index of refraction here. Examples are diamond and glass. Now let's have a sample problem here. We're going to calculate the angle. So the air, the index of refraction of air is n equals 1, and we have a given earlier that the index of refraction of glass is going to be 1.5. So this thing, there's a light ray that hits it, and it gives off 40 degrees of angle. And okay, let's call this n sub 1 and n sub 2. So in order to calculate the theta 2, so this is going to be theta 1. Okay, we're going to calculate theta 1. Okay, now, so our n sub 1 is going to be 1, sine theta 1 is going to be this, so we're going to calculate it. And n sub 2 is going to be 1.5, and the sine 40. This is multiplication. So let's move it here. So I'm going to take the arc sine of 1.5 and sine 40. Okay, now to calculate this thing, what we now have is 74.62 degrees. So as we can see, it basically moves away from the symmetry. So why is that? So if n sub 1 is greater than n sub 2, it will go closer. But if n sub 2 is greater than n sub 1, then it will basically bend away. So the example is what we solved earlier, which is 74.62 degrees. The index of refraction of glass is 1.5 and there is 1. So now what is critical angle? So this is theta c. Critical angle when the angle of refraction becomes perpendicular as it travels at the x boundary. So we still have this. So basically the critical angle is when the other ray, the refraction ray, is now perpendicular. So we form a 90 degrees here. So in order to calculate that critical angle where the light ray will become perpendicular, we're just gonna plug in some values here. So there you have it. So we just use this Snell's law once again, and basically put some values. So the critical angle is going to be around 41.8 degrees. And that's basically it. Hope you learned something, and goodbye.